Okay, in this video we want to talk about more stuff with inverses and determining if inverses are functions. We can find inverses of functions graphically, and we talked about in the last video about how two functions are inverses, or two graphs are inverses if they reflect over this line y equals x. And so what you can see right here is an example of a function f of x. This happens to be an exponential, and if I reflect all of the coordinates over the line y equals x, I get this other graph here. And if you were to ask yourself, is this inverse, is that red graph that appears, is that a function? I want you to think about how we determine if graphs are functions, the vertical line test. And this actually does pass the vertical line test. I do have a little bit of an asymptote here, but it still would pass the vertical line test. Compare that with this function. I think it should be somewhere under here. There it is. Compare that with this function that you kind of see animated on this screen here. I have a parabola, and when I swap all the x and y values, reflect that thing over the line y equals x, I get the inverse of this function. But if you look at what shows up here, hopefully you can tell pretty quickly this is not a function. The graph that looks something like this is not a function. It's kind of like a sideways parabola. It does not pass the vertical line test. So what we've learned from this is that taking an inverse of a function does not always yield a function. So there's a special term for when it does. We like this guy. This is extra special. This guy is, just okay. And we give a special name to functions where their inverses are also functions. We call this one-to-one functions. Let's define a one-to-one function. I got a whole lot of terms here for you. A function for which every element of the range of the function corresponds to exactly one element of the domain. One-to-one is often written like this, 1-1. A one-to-one function is a one-to-one function if it passes both the vertical line test and the horizontal line test. This is the big kicker. So you know how in the vertical line test we said that it's a function if a vertical line can pass through all of the points and we only have one intersection? Basically what that was doing was that was determining that you have only one output for every input. If I perform a horizontal line test, what I'm doing is I'm really checking that there is only one output for any given input. So that's what this is about here. Every single element in the range, every y value, has only one x value associated with it. So a one-to-one function has to pass a vertical line test and a horizontal line test. Something that might not be one-to-one is something that can look something like this. If you were to imagine me rotating this about the line y equals x, making an inverse, it does not pass the vertical line test. Or you can kind of eyeball this thing. It does not pass the horizontal line test. Therefore, the inverse is not a function. All right, so there's a quick test that you can eyeball this thing. Let's talk about some points. I have an example here. I wanted to determine if this function f of x is one-to-one. And really, at the end of the day, I'm just making sure that there are no repeated x values and no repeated y values. This already is a function, so I don't need to look at the x values, but now I just need to look at all the y values. So I've got a 3, a -5, an 11, and a 4. All those y values are unique. Therefore, I have a one-to-one function. Easy as that. Making sure that there are no repeated y values or repeated x values. So here's an example I'd like you to try. Pause the video, look at these points, and determine if this function is one-to-one. And it turns out, no, I'm sorry, this is not a one-to-one function. Sorry, h of x. You're just not quite that special. -9 is repeated in my range, so this is not a one-to-one function. Why don't you try this example as well? This is with a graph, not with points, but I want you to see if you can apply what we just learned to determine if these are one-to-one functions. Pause the video, give it a shot. And it turns out that one of these is, one of them is not. This one fails the horizontal line test, so the inverse is not a function. That means that only the one on the left here is a one-to-one function. In the next video, we're going to do some more practice with inverse functions and kind of get a little bit more algebraic with this stuff.